Okay, it's 2 minutes after 1. We will go ahead and get started. Welcome everyone to the Michigan Historic Preservation Network November webinar. My name is Xiaohan Bao Smith. I will be your moderator today. And today we have Craig Lydell from Grand River Builders to talk about pouring new wine into old wineskins, most common exterior repair mistakes, and our questions of new versus old. Before we get started, I would like to go over some Zoom items. First, if you have any questions, please type them into the Q&A box as you think of them. Questions will be answered at the end of the presentation. And the chat box will be used to share links or resources discussed during the webinar, and feel free to share your thoughts through the chat box too. And if you don't see the Q&A or chat box, please wiggle your mouse. They should be at the bottom of your Zoom screen. And please participate in the survey after the webinar concludes. This webinar will be recorded, and the recording will be available in the next few days. You will receive an email when it is available. If it's your first time attending our webinar, we are the Michigan Historic Preservation Network. We advocate for Michigan's historic places to contribute to our economic vitality, sense of place, and connection to the past. We could not do the work we do without our members and volunteers. So if you are not a member yet, please consider joining us at www.mhpn.org. Our webinar series is sponsored in part by an award from the Michigan Arts and Culture Council. And it is my great pleasure today to introduce you our speaker, Craig Lydell. Craig is a general manager for West Michigan's leading historic building restoration company. He has managed numerous restoration projects, including some of the historic churches in Grand Rapids and many notable historic buildings in West Michigan. Craig has a bachelor's degree in business with a major in marketing from Ferris State University. At the age of 40, he turned in his tie for a tool belt and has spent the last 15 years in both commercial and residential buildings. A large majority of his experience is in hands-on field work with historic buildings. Areas of expertise include the technical knowledge of historic building materials, technical history of buildings, and field skills including carpentry, sheet metal, and masonry. And with that, I will go ahead and turn it over to our speaker.
Thank you, Xiaohan, for the introduction. And let me get everything started here. And welcome, everybody. Thanks for taking the time to listen to the webinar. We've got a lot to cover, so I'm going to go ahead and get right into it. I'm the general manager for Grand River Builders based in West Michigan. We do a lot of building, as Xiaohan mentioned, on historic buildings in West Michigan and really statewide. To give you a little bit of my background, as Xiaohan had mentioned, a lot of my experience is field work. So if you've ever been on a job site or seen a building being worked on, and there's the guy who's got the tool belt, who's getting ready to go up onto the scaffolding and work on the project, and you've ever wanted to ask him what he's thinking is actually going on, that's more the perspective that I'll be bringing to this talk. I'm not trained as an engineer or as an architect, but I do have a lot of hands-on experience in seeing things that have been done in the past well, and also things that have not quite gone right. So the title of the talk, pouring new wine into old wineskins, comes from the idea in the past wine was stored in wineskins. And if you poured new wine into an old wineskin, the old wineskin actually couldn't adjust to the new wine as it expanded, and it would actually cause the old wineskins to burst. So can we take new methods and new materials and put it into our old wineskins and not cause them to burst? So that's sort of the theme I wanted to take with this talk. Our objectives are going over three main areas: masonry, boxed or built-in copper gutters or gutters, and slate roofs. Now, in order to go over every possible scenario that we could have happen to us for repairs on a building, we wouldn't have enough time to do it in an entire day. There's so many different scenarios that we come up against. So a lot of the discussion I'm going to have today is going to be based on the materials themselves that will help you be more educated about the buildings and how to best approach repairs. If you don't understand the materials and it's just a one way of approaching everything, things won't work out. So let's get started. We'll start with masonry. Some of these pictures are probably something you've seen out in the world and some of the historic buildings. And unfortunately, a lot of it was due to poor repairs. The first thing we need to look at is in regards to bricks themselves. They are under two forces most of the time. They're either in a compression state, they're trying to be compressed, or there's a state of tension. And tension is something that's inside the brick that's trying to move itself out. So looking at the compressive strengths of brick, a brick can handle up to 400 to 500,000 or 5,000 pounds per square inch in the older bricks. This would be like your Milwaukee Creams or your Chicago Commons that you see in a lot of the older buildings. Some of the modern bricks today that they make can handle up to 10,000 to 13,000 pounds per square inch. This is the compressive strength is why we build old buildings with bricks. They can handle a lot of weight and they're a great structural product. The tensile strength of a brick, though, is very low. So if there's something inside the brick that's trying to move out, the brick and masonry can really only handle 400 to 500 pounds per square inch. And this is consistent with both the older bricks and the modern bricks. So brick masonry has a very high compressive strength, but it has a very low tensile strength. So let's take a look at the most common factors that act on masonry with tensile forces. The two things that will act on masonry are water and rust. Now, let's first take a look at the rust. If there is something inside of masonry and it's steel or an old iron bar or something like that, and it starts to rust, it can exert up to 9,000 pounds per square inch on its surrounding materials. And now remember, the tensile strength of brick is only 400 to 500 PSI. So you can imagine what is going to win if rust is acting inside a masonry unit. So some examples of rust acting on masonry or concrete. This is probably something we've all seen, whether it be like a fence post or something that's let into a concrete slab. It will start to rust, and as it expands, it'll literally blow the concrete apart. In this example here, this is a limestone column on the outside of a residential home in Grand Rapids. And when these columns were put together, there is actually pins that are put in so that each column fits into itself. Those pins inside these limestone columns actually started to rust. And as they rusted, they started to expand and blow apart. You can see where the joints are on these limestone columns. They've been caulked. Different attempts at repairs have been made on this. But what happened in the beginning is that the mortar joints weren't kept an eye on. Water seeped into those joints and caused this to blow apart. Another example is limestone blocks or even sandstone blocks on the outside of buildings are sometimes keyed together in these old buildings with like a steel bolt or a lag or dog that they'll call them. And if water is able to get into that wall and start to rust, you can see what starts to happen. the rust will start to expand, and it'll start blowing out parts of the brick all across the building. So if you see something like this, it's typically a steel or an old iron bar that's inside the wall. This is another example. You can see on the blown up picture to the right, you could possibly even see the steel or the iron bar that's in there. And it's gotten wet and it's expanded and actually blowing the masonry apart. Now, rust can also act on bricks in a compressive state. So it'll actually grow in between. Now, in the past, lintels over doors and windows were made of stone, or they used a gauged brick or archways. But probably late 1800s, it's not really known for sure, but lintels were started to be made out of steel. And if this steel starts to have water get to it and starts to rust, it'll literally start to push buildings up or push whole walls up. This is probably something you've seen in some places. I will get calls where folks will be concerned that their building is starting to shift and they're seeing giant cracks going up the side of the building. They're concerned about foundation issues or things like that. But you can see in this example here, on the right side of that top part of the window, the lintel has actually rusted and started to expand and has actually pushed this entire wall up. Repairs, you can see, have been made in the past, but that mortar joint is quite thicker than other areas on this wall, which is the evidence that this repair has been tried to be fixed in the past, but it continues to rust and continues to push things up. This would be another example of something like that. The window would be on the right, and you can see where prior repairs were made to try to hide the fact that the wall was pushed up due to rust jacking, is also the term, but the rust has pushed this wall up. Now, not every one of these step cracks will go up. Sometimes I've actually seen the step cracking go down. It's just it's gonna push whatever weakest part of the wall is, or whatever is easiest. Once these cracks start to happen, they can't be sort of pushed back together. Once that crack is there unless the entire wall is rebuilt. So repairs on this have been tried to be made at a residential house, but it certainly is seen. This is an example of a stone pier out inside of the front of somebody's house. They used the iron bars to hook these chains onto, and those have started to rust and actually blew apart these masonry piers out in front of a historic house in Grand Rapids. Now, not every time that you see a step crack is it going to be caused by rust. This actually was caused by a tree grew right next to this house in that corner there. The homeowner decided to cut the tree down, and then the root system rotted, and then the whole foundation started to fall down in that corner. So just because you see step cracking doesn't immediately mean it's being caused by rust, but that is one of the factors. And so not every step crack is rust caused. So what are some action steps that you can take? I would recommend you visually inspect the building for areas of exposed steel components. If you find any steel, I would recommend that you have it cleaned. So wire brush if you need to, paint it with a rust inhibitive paint and cover it if possible. That is the best thing to do. The wings on the window, so in that picture in the bottom right, if you tried to put mortar in that joint, the joint is not deep enough for the mortar to stay. So in a case like that, I actually recommend that you use a modern day caulk in this situation. You can get you can get colors that are close to the mortar, but a caulk is going to be able to work within a joint that is much more shallow than a typical mortar joint. And that will also help protect the metal from getting any more water on it and causing it to rust. Now, when we look at water, water also exerts forces on different materials, different building materials, a capillary pressure of water. So water just naturally traveling through say a brick, we're going to use bricks here as an example, can actually exert up to 300 to 500 pounds per square inch as it moves in and out of a brick. But the masonry can handle about 400 to 500. So most of the time, capillary pressure is not what's causing problems to the right. There is something called osmotic pressure. This is where water is more or less being forced through a material, and that can exert up to 3,000 to 500 pounds per square inch. So remember, the tensile strength of the brick is only 400 to 500 pounds per square inch. An example of where this is important is actually the time of year we're heading into right now, which is the winter. So you have the inside of a building has interior or high pressure, humid type place, and outside is cold, low pressure, and the water from inside the building wants to move through that wall and get to the outside. The high pressure wants to move towards the low pressure. Now, in modern day buildings, they're built differently. They have rain screens. The structure of the walls themselves have different layers in order to handle some of this movement. But in the old historic buildings that are just masonry built, this is not something that can be done. The water is going to want to move through the masonry wall completely. There isn't those protective layers like we have nowadays. So as the water wants to move through that masonry wall, it's going to find the easiest path possible. Now, the best case scenario is that the mortar joint is more permeable than the brick itself. Old mortars like lime mortar allow water to pass through it a lot easier than more modern day mortars. And we're going to get into this a little bit more. So if the water can't move through the mortar joint, it's then going to find the next easiest path, which is through the brick. And as you saw earlier, if there's a good amount of pressure of water being pushed through a building material like a brick, you'll start to actually see the faces of bricks start to be broken off as that water moves through with that osmotic pressure. An example of that would be the picture to the left, where it shows you that that wall was repointed with a mortar that was too hard for that wall. So the mortar joints stayed exactly intact, and it blew all the bricks apart. I'm sure we've all seen this as we've driven around or seen older buildings. So you get to the point where you have your building and you need to repoint it. Mortar just over time will start to fall out of the joint and need to be repointed. So we go to the National Parks Service Preservation Brief on repointing historic masonry. And there's areas that they point out that are the most important. They want color, texture, and tooling to be matched. They want the sand to be matched. They would like the mortar to have greater vapor permeability and be softer, and as vapor permeable or as soft and softer as the original. So I'm going to touch on each one of these quickly here. So color, texture, and tooling. With texture and tooling, you really need a skilled mason who is familiar with the different types of mortar joints and how to tool them properly so that they match the existing building. I'm going to have some information on that on the next slide. The color is going to be also accomplished by somebody with experience. And when they do color samples, you can use dyes, a powdered dye, to mix and match and try different ways to try to get a good match to your existing mortar. Now, the best way to go about it is to grind out a few areas in your wall, try a few color samples, and actually install it into the wall and give it a day or so to start to dry out, and then see if that color comes close to the existing mortar. That's the best way to go ahead and do that. But what I would also recommend is not to do spot repairs. I often get asked by folks, hey, can you come out here? I just have a few joints here or there, just a few holes. Can you just fix those holes or just those head joints, just replace those? The problem with that is that was done on the picture to the right, and you can see all the head joints are quite bright. When this was originally done, the mortar matched exactly perfect with the color. But over time, the surrounding drier bricks sucked all the moisture out of the mortar, which caused it to lighten and lighten more over time. So if you're going to repoint an area, what should have happened with this wall is just this whole section should have just been repointed at the same time, as opposed to just the little spots here and there. The amount of labor it would have taken to just do that whole section was probably just a little bit more than just trying to do all these different spot repairs. So I really don't recommend individual spot repairs all over a wall. Now, the different types of mortar joints you're going to see in historic buildings in the area are the ones that are in the red box. Probably the most I see are the bottom two, the raked and the flush joints. Those are the ones we typically see. In the upper left-hand corner is the mortar joint called concave. And this is a mortar joint that is used almost exclusively in new building now. The reason why is it's thought that it's better at shedding water off the wall because of its concave shape. The problem is that you will not see this in any historic buildings. This is a newer type of mortar joint. But the problem also is that most masons nowadays work with this joint and work with this joint exclusively. And they use a tool that looks just like what I showed there. It's got a curved edge to it, and it's just quickly struck. Now, when I looked up this tool online to see if I could purchase it on Lancaster Limeworks catalog, they couldn't have said it better than I could. It creates a perfectly round joint, but this joint style is generally not historic, but is usually used in today's repointing. I can't tell you how many historic buildings I've seen repointed and then get struck with this joint, and the wall looks completely different. The reason is the way light reflects off of the different aspects of the wall. A concave joint as opposed to a rake joint looks very different. So I really recommend that if you are having your wall repointed, that you specify that the tooling of the mortar joint is done to the original, not just have it be repointed. You really want to specify. If you see that tool on your job site, make sure it goes away. This is not the way old buildings should be repointed. So stop doing concave joints in your masonry repointing. Now, the sand that must match the sand. If you go to the store, like a Home Depot or Lowe's, or really a lot of suppliers that supply masonry cement, a lot of them are going to give you in the premix a play sand, which is the one on the left. It's very versatile because it can be used in almost any size joint. The problem is that's typically not what you see in most historic buildings. The mortar sand that you may see if you try to buy just plain mortar sand is going to be what's called number 8. But then you will also see what's called number 4 sand. Now, the numbers just represent how many sieve openings there are per inch as they shake out the sand to get the aggregate. Most buildings, most historic buildings have either number 8 or number 4 sand. Now, you can the contractor can purchase the cement and the sand separately and make their own mortar mixes, which is what I highly recommend. This wall here, could you imagine if this joint was repointed with play sand? How much this joint would look different? And if it was also struck with that concave tool, you would completely change the look of this building from what it was in original intent. This unfortunately exemplifies a lot of the things that I was just talking about. The joint was raked with one of those concave tools. This mortar is the typical gray color that you will just buy anywhere, and unfortunately is used often, but you can see how much it changes everything. So the preservation briefs also talk about having a greater vapor permeability and be softer. The best mortar for an older building, so if you have a Chicago Common or a Milwaukee Cream brick, would be a lime mortar. Remember, this is where the interior high pressure is trying to move through the wall, so we want to make sure that the mortar joint is more permeable than the brick. So how is lime cement supplied? A lot of contractors don't work with lime, or they may say they work with lime, but The way the lime is supplied is there's a natural hydraulic lime. It's the numbers you'll see NHL 2, 3.5, and 5.0. The numbers refer to a compressive strength in British terms. There's also a hydraulic lime called pozzolan, which is a lime that they add some volcanic ash in order to help it set up a little bit quicker. And those compression strengths are 3.5 and 5.0. The NHL 2.0, really the places where that would be useful is if you have a highly ornate masonry structure or a very detailed limestone piece that you want to just fill in the joints. It's not going to be a structural type of mortar. Then the NHL 2.0 is a great product. But if you're just going to be repointing walls, I would recommend you go more with the 3.5 or the 5.0. There is a lime cement that is out there called Miracle Lime. This lime should not be used as a cement. This is actually added to Portland cement to make it more workable. So if somebody thinks that they're working with lime mortar and that this is it, this is not lime mortar. You want to make sure that the contractor is buying either the natural hydraulic lime or the pozzolan. So why don't we use lime more often? Well, it's labor intensive. As you can see on the picture to the right, lime mortar cures with moisture. It doesn't cure by drying out. So we hang canvas tarps on the wall and we keep those canvas tarps moist for a good couple of days. That gives the mortar a chance to carbonize through moisture as opposed to drying out. So that does make it more labor intensive. One of the things that can be seen is if the mortar is not colored, you're going with a straight white mortar mix, you can actually see the blue in the picture on the right. First time I saw that, I thought something was wrong with the mortar, but I actually found out that that's a good sign that the mortar was kept moist enough to cure properly. That blue coloring went away in a week. But that's actually something that a mason should look for if they're not coloring that mortar. So pros and cons of lime mortar: greater vapor permeability. It's softer than the brick. It's actually known to have some self-healing properties. It meets all of our preservation brief guidelines, and it's really the best choice for historic buildings. The cons are it's going to take a higher level of skill from your mason. It's not as readily as available as spec mix or other masonry cements. So you're not going to run up to the store if you run low on it and get it. So you're going to have to really know how much material you're going to need before the project starts. And it's more labor time. So that means it's going to be a more costly, expensive way to do that work. Some action steps is, first of all, if you're a masonry contractor, doing one small job with lime mortar does not make you an expert. There's a lot of things to learn, and you really need to spend time working with this mortar. If you are running a project, you really have to have realistic scheduling and costs. This is not something that's going to be, if you typically have a set system of we set aside this much time for masonry repointing, expect it to be more. Ask the contractors for project referrals where they actually use lime mortar. And really, the building owners need to be more educated. You need to ask the contractor for specifications. And if you feel overwhelmed, use a consultant if necessary. The Henry Firk Sons in Chicago is a company that's a great company and a great resource. I would highly recommend contacting them. So let's get into boxed and built-in gutters. There's 3 different types of built-in gutters or box gutters that you're going to see. The one on the left is a single wall, has a flat bottom, so it's plain. The second is a double wall gutter. This gutter will have a cornice with a gutter liner installed. So the slope of the gutter is actually built into the gutter liner. So when you're looking at this gutter from the ground, the cornice will look flat and level, and the gutter liner will actually have the slope built into it. And then there's also the wood framed gutter where a gutter liner is just installed into it. So the slope and all the framing is all built out of wood, and then that is lined with metal on the outside. Now, the metal is formed by what's called a cornice break. This is what we have in our shop. Each job has its own specific specifications. So you're not going to go to the store and buy something that's extruded or off the shelf. Every single gutter system needs to be bended and folded individually. So one thing to keep in mind is that 10-foot long distance of what these cornice breaks are, because that's going to be important for you to know here in a minute. Where most things can go wrong with these gutter systems is not knowing about building material and expansion and contraction. These building materials will move as they get cold and as they heat up. So a 30 lineal feet with a change of temperature of 100 degrees and the following building materials will move that much. So steel will move 0.24 inches, copper can move up to 0.35 inches, aluminum can actually move up to 0.46 inches, and so on. An example to the right is a built-in gutter system that was built without taking these things into consideration. So that soldered joint there cracked because the metal started to move inside that joint and had no way of moving back and forth freely. This has got to be taken into consideration when these gutters are either repaired or installed. So a typical gutter installation is going to have one end where the downspout is located will be fixed. So we'll secure that spot either through a nail that'll have a soldered patch over it or something that will hold that part of the gutter in place. And then the rest of the gutter will want to expand and contract along the length of it. If you look at the picture on the bottom, you can see that there is a hook in the gutter. So it's actually like a channel that the gutter is hanging in, so the gutter can move freely. The gutter is installed on the roof inside that channel. So the gutter that's carrying the water is not nailed to the roof, but that clip above it is. So the gutter can slide freely inside that channel. This is an example where if you have a long gutter run where there's a downspout on either side, you would fix either end. So you'd fix all the way to the right and you would fix all the way to the left. And then in the middle where that gutter would meet, you will leave a little bit of space for both sides of that gutter to expand and contract. So that middle picture there is showing the ends of each gutter. Now that gutter, it's not open where the water is going to go inside that joint. There's actually a vertical piece that has been soldered on either side in that middle picture. And then after that is all put together, a metal cap is put over it, as you can see in the picture to the right, to keep water from getting in between those two gutter systems. But this expansion joint will give both sides of the gutter the ability to move back and forth freely without putting the stress on the solder joints. This is very important. This is an example of a gutter system where somebody tried to just nail everything down. You can see that the gutter and the metal started to move and actually started popping the nails out of place. You're not going to be able to hold metal back when it expands and contracts with nails and fasteners. This is typical. What we see when I go out in the field to take a look at gutters is there's a whole bunch of caulk in the solder joints in the places where there are no expansion joints, and the overall design of the gutter system was not done right. So if you remember from the other picture of the cornice break being 10 feet long, you'll typically see a caulk joint about every 10 feet, because that's where two pieces of metal will be put together. And if it's not properly designed, that's where they will start to fail first. The one all the way in the left, somebody attempted to fix that gutter system with a whole bunch of TPO roofing tape. It didn't work. So with this in mind, let's go on a call. So I get a call from a homeowner who says they have soffit damage. So the picture on the right's a little blurry, but right above that window, they're seeing all sorts of damage in their soffit of their, right underneath the gutter. So if we get our ladder and we get up there and we sight down either side of this gutter system, you would want to think, okay, what do I see or what do I not see? Well, one thing I do see is I don't see any expansion joints along this whole gutter run. Now, this gutter run is about 30 feet long. So you're going to want to, first of all, look for expansion joints. There is a caulk line or a patch about every 10 feet. And then unfortunately with this roof, it's asbestos roof shingles. So it's going to be very difficult to take those asbestos roof shingles out, repair the gutter, and put them back in. This is the layout of that same house from looking up above. So if they decided to replace the gutter system and keep the built-in gutter, this is where the downspouts are. And if we can, we'd like to keep the downspouts in the same locations. Sometimes we have to move them in order to have that fixed point and to have the expansion joints in the proper areas. But when we're looking at this house and we think about, okay, if we rebuilt this gutter system, where would we put the expansion joints? The first place we could put them, the green lines would show you where we could put them. So we would put one in between the long runs on the two downspouts, just like that one picture I showed earlier with the expansion joint in the middle. We could put two expansion joints on the front of the house by that dormer, because those can be, because you can have an expansion joint at the end of a run there. And then we could also put one on that bottom section on that hip area, on the bottom of the hip. So you could rebuild this entire gutter system if you wanted to, and not have to change any of the appearance on the downspout locations. So your action steps, if you do have a gutter system that's copper or an old system, sometimes they're the old tin, turned metal gutters. You want to work with a qualified contractor who understands the thermal expansion and contraction of these building materials. You can't just get somebody who knows sheet metal and how to bend it and they throw it in there. Those will typically fail. Don't try to restrict the movement by using fasteners or adhesive caulks. This is probably one of the biggest things I see happen. People will go in and just start putting nails and fasteners in all over the place to try to stop it from moving, and you won't win. You won't win with that. But you need to understand that you have more options than just covering up these old gutter systems with plywood and then installing gutters out on the eaves edge. These can be done. Yes, they are more expensive to rebuild a gutter system than putting like an aluminum case style gutter on the outside of your house. But it is possible to fix these. All you need is somebody who understands the expansion and contraction and who can lay out a proper design of a gutter system. Those gutter systems can last you over 100 years easily. So let's move on to slate roofs. How is slate supplied? Well, slate is applied in ranges from 3/16 of an inch to a 1/2 inch thick. Majority of the houses or buildings that you see in Michigan are going to be anywhere from the 1/4 inch to 3/8. And typically when you get a pallet of slate, it's going to be they're going to vary in between that 1/4 to 3/8. They'll not guarantee that every single slate is going to be exactly 3/8 inch thick. They're graded based on their expected life. So if you have a grading of S1, then they're expected to go 75 years. S2 is 40 to 75, and S3 is expected to go 20 to 40 years. So if somebody is speccing out a project or they're looking to have a slate roof put on their house, one of the questions that should be asked is, am I getting an S1 slate? Am I getting S2, S3? Because most people are going to want S1. If they're going to go and keep a slate roof going, you want it to last a long time. The grading is based on water absorption, weather resistance, and how flexible it is. So if you have a slate roof, what grade do you have on your roof? Maybe you have documentation from the original installation. Most of the time, no. Most of the time, most people don't have that. So if you don't have any documentation, you can find, hopefully, an experienced qualified contractor. How would you go about doing that? Well, there is a group called the Slate Roofing Contractors Association. They have a lot of contractors that are certified in slate. You can ask other institutions. I highly recommend this. If you see another building in your area that has a slate roof and it looks like it's being well maintained, ask the business owner who they use to maintain their slate roof. They will probably know who is out there, and if they've had that slate roof for a long time, they probably know who to call and who not to call. Another resource would be roofing distributors. These are the companies that are going to supply the materials to contractors. A lot of these roofing distributors are also like an asphalt shingle type distributor. A large one in our area is called Eichenhout, but you can find out who most of the contractors work with to get their supplies of slate and ask them, who would you recommend that I contact to have a slate roof either maintained, installed, repaired, or anything like that. Those would be places I would start. That contractor would start out with a visual inspection. This is a roof I looked at. The homeowner called because they were concerned that a slate had slid out of their roof. Now, if you're looking at it, you can see the tremendous amount of delamination on the slate that is about 2 or 3 rows below the one that's missing. Shockingly enough, this homeowner has not called me to let me know that their roof is leaking. They were just concerned that a slate had fallen out. So slate roofs, if you have enough slope, can really last quite a long time. But this roof here is beyond serviceable. We were able to get a piece of slate up into that spot and keep it going a little bit longer. This slate roof this picture was taken about 5 years ago. They still haven't called me, and I've driven by and they still have this slate roof. So it's amazing how long and how much you can get away with on somebody's slate roofs. But the delamination and the texture of the slate, if it starts to get soft, is the first signs that you've probably got maybe 5 years left on that roof before it's completely done. This is another example of some pieces that have fallen apart. These slate are starting to delaminate, so they need to be replaced. So why do some slate roofs fail? This is a question I often get. I wish every slate roof I went up to, I would see this every time, because this would make it easy why there's leaking. But unfortunately, it's not always this easy. Most slate roofs fail for the same reason that asphalt shingle roofs fail. It's a improper flashing installation. Sidewalls need step flashing on slate roofs, and they should be made out of copper. Copper, if you're going to put a slate roof on your house, a material that's going to last 75, 100 years or more, you should have a material that you're using for the flashing that'll last just as long. So I recommend, and we only use copper flashing on our slate roofs, but caulk is not a solution, especially in these locations where slate is meeting a sidewall. Another reason why they fail is poor installation methods. This is a roof I went out to look at, and after asking a lot of questions, I found out that this roof was actually installed with an air nailer. So there was really nothing we could do to fix it. All the slates were cracking, they were starting to slide out, and the original installation of this roof was just all wrong. And all of this was happening within the first 5 years that this roof was installed. So this is another reason why it's really important to find out who the contractors are that you can work with in your area. Poorly executed repairs will often drive people to think that, oh, forget it, my slate roof is no longer any good, I just need to replace the whole thing. Every year I call somebody out here to do repairs, and I want to be done with it. That should not be the case if somebody has experience working with slate. The one on the left, somebody just drilled some holes, put some nails in, and used some caulk. The roof tar was used in the middle one. The one on the right, the valley, they actually had a piece of rubber roofing that they stuck down onto that valley to try to keep the water from going in. These are all repairs that were not done properly. So what is a proper repair method for a broken slate? There's a tool called the slate ripper that we use. It's in that picture there. It has a hook, and you slide it up under the slate. It grabs the nails, and then you pull the nails out, and the slate will slide out. So a great example of the method or the process that you would use to repair a slate is from Joe Jenkins' book called The Slate Roof Bible, which I would recommend. It's a good book. It's got a lot of great information in it, but he shows right in there the process of replacing a broken slate. and not anywhere in here will you see a caulk gun or anything like that, or roof tar. Slate can be repaired easily if it's done properly, and you can save it. Now, when you're working on the roof, it's important not to walk all over it, mostly for safety reasons. Slate is rather slippery and you will slide and fall down. But what we will typically do is we will build out walk boards, like in the pictures here. And after you're tied off, you can easily walk around the roof and work on it without actually stepping on the slate. The walk boards push the weight of the person out over a few pieces of slate instead of directly right on one slate. So action steps for a slate roof is you would want to work with an experienced qualified contractor. The first place to investigate if you're finding you're having all sorts of leaks is start with flashing and valleys. This is almost 90% of the time where I find leaking roofs. It's rare when out in the field if that's the first place where leaks are happening, unless a slate has been broken off and is sliding off. As you saw in that picture before, where the slate is completely delaminated, that person was still not seeing leaking inside their roof. So you always want to start with sidewalls and valleys. If you are going to have some work done on your building, you want to purchase an inventory of slate. Slate is not something you're going to run up to the hardware store and buy. It's always good to, if you're going to go through the effort of having repairs done, get a few extra 100 pieces of slate or 100 pieces of slate and just keep them in the basement or somewhere in the building, so that when you do need repairs down the line, you can have pieces that actually match your roof, as opposed to all sorts of varied colors that don't match. So I would highly recommend you invest in an inventory of slate. The fasteners should be copper roofing nails. That is the best. Galvanized asphalt shingle nails or just plain old roofing nails, I don't recommend. They will rust over time, and then those rust streaks will go down your slate roof and be quite unsightly. I don't recommend screws. There's some manufacturers that say that you should use screws because it holds it down better. Problem with that is whoever wrote that specification never repaired a piece of broken slate. So as you remember, with that slate ripper, we slide it up and we pull the nail out. If that nail is not smooth or ring shanked and it's a screw, you're not going to pull it out. You're going to have to get a very long demo blade on a Sawzall, and you're going to have to try to feed it all the way up there and try to cut those screws. So I really don't recommend using screws on a slate roof. All your flashing should be copper. And you should really follow that slate roof Bible recommendations for repairs, using a slate hook or a copper bib after pulling the slate out with that slate ripper. And caulk and roof tar are really not the right solutions. The best rated caulk has maybe a 5-year life on the exterior of buildings. So to remember that proper installation materials and repair techniques are a better investment than caulk. So I can answer questions now. If for some reason we don't get to your question, I'm leaving you my email. Feel free to email me at any time. If you have any questions, I'd be more than happy to answer them after the webinar is over as well.
Hey, thank you. We will just leave this slide up so people can write down your email address. Well, thank you so much for the presentation. That's very, very informative. And we will just get to the questions right now.
Sure.
So first one, is it acceptable to use chemical that dissolves rust before painting?
Sure. You can, if you want to, sure. The only concern I would have with using a chemical is if that chemical gets on other parts of the masonry and it can discolor it, you may want to test it first in a spot to make sure that it doesn't, if it does run down the side of the building, you then don't cause another aesthetic issue as far as seeing a chemical stain going down the side. As long as the chemical doesn't stain the brick, you should be fine. You're really just trying to get that rust to stop and then get it coated with a rust inhibitive coating. So I'm not opposed to it, but I would just certainly test it first on another part of the building that's not seen to make sure it doesn't damage the brick.
And the second question is regarding the difference between the pressure inside and outside that makes the water moving. So the question is, how can we better vent our historic homes that has multiple showers being taken each day and dishwasher running, clothes being washed?
Yeah, it's a good question. It's when these buildings were made, when they were built, they weren't built with lots of showers and lots of dishwashers and things like that. So that's a good question. As far as there's different types of ventilation mechanical equipment that's out there right now that can be looked into as far as changing the air inside the house and moving the air through. That's certainly a possibility that I would look into. If I owned a historic building I was living in and I was introducing a lot more moisture into it than originally was there when the building was built, I may look into a qualified mechanical contractor to see if he could do something as far as helping the air move. One of our obsessions with having everything so airtight with newer construction isn't the best idea with some of these older homes. So the fact that sometimes the windows are a little drafty, or you just feel a breeze here or there in the older buildings, that's okay. If we start spray foaming the whole inside of our historic buildings and trying to shrink wrap everything, we can actually start to cause more problems than what we had in the past. So first thing I would do is call a mechanical contractor on that situation.
Next question. When a slate roof begins to delaminate, you mentioned some of the things that can cause it, but could it simply be the slate wasn't in good quality at the first place?
Yes. Yep. And the gradings, those gradings that were shown, the S1, S2, and S3, if you don't know what grade you have, sometimes the grading of the quality of the material just wasn't that great back then when the roof was originally installed. One of the things that should be done when a new roof is installed is every single slate should be what's called hand rung. We actually have a guy on the ground with a hammer who lightly taps the slate to hear if there's any imperfections inside, the slight cracks that your eye won't pick up, because it'll make a different sound. So every one of those should be checked before going up onto the roof. I've seen that happen a lot where that's not done, and then all of a sudden slates sort of crack and start to slide out. So little things like that can make a difference between a roof lasting 20 years and over 100 years. But the quality of the slate, yes, there is different qualities of slate. Almost every new slate purchase nowadays are all that S1 grade. And a lot of the slate comes out of like the Vermont area. So very few wholesalers or distributors are going to sell anything less than an S1 slate now.
Next question. Returning to the discussion on masonry, can you say a word on installing a brick floor with regards to best type of bricks to use and possible sources for appropriate historic brick in West Michigan?
A brick floor. What if the person can answer? Are we talking about interior or exterior brick floor? I'm assuming exterior. I would assume exterior. If it's an exterior, most pavers are good. What I don't see work very well in exterior masonry or brick floors are mortar joints. A lot of times people will try to treat them as if they were a vertical wall, and the mortar will break and fall apart. It should be a loose sand, or like a play sand would actually be used in the joints of something like that with like a chipped dust type of base layer to it, in order to allow that brick to move around a little bit. But yeah, most landscaping contractors could probably help with that. We don't really do a whole lot of brick paver type work, but there's a lot of bricks out there that you can find that would be a good match.
Okay, so it says It's for a carriage barn.
Mm-hmm. Mm-hmm. I would actually, I would encourage that person to email me, maybe with some pictures and areas that they're wondering about, and I'd be more than happy to answer those questions for them.
Okay.
Yeah.
Okay, next question. If you are recreating an historic mortar joint profile, and it's one that extends past the face of the brick, for example, when they are made to look like rope,
Mm-hmm.
are there special considerations in terms of mortar mix?
You could still use the same mortar mix you would use on the repointing. On an extruded joint, I would most likely, if I was using lime mortar, I would certainly use the pozzolan hydraulic lime as opposed to the natural hydraulic lime. The pozzolan is, it tends to set up the chemical structure after it sets up is a little stronger than the natural hydraulic lime. If somebody was brand new to lime mortar repointing, I would encourage them to start with the pozzolan product first to get familiar with that. That acts the most like a Portland cement type mortar, but it does have vapor permeability into it. But I would probably use the pozzolan and maybe a 5.0 because it would have a slightly stronger setup than the others. But you could, outside of that, you would still use the same techniques as they used in the past for extruded joints. And there's different types of tools and ways of making those extruded joints.
Okay, next question. Is there any roofing material that simply shouldn't be used in climate like Michigan's?
I can't really say there's a specific roofing material that shouldn't be used. I can say in West Michigan, slate and metal roofs are really great in handling our climate. Both of those are very good materials where I would start with first. Asphalt shingles are obviously the most economical and easiest to use. But if you're looking for a long-term product, I find that the slate and metal roofs are great options for all the different seasons that we get here in West Michigan. So that's where I would start.
Next question. What are the special challenges of working on the historic church?
What are the most challenging on working on a historic church is a lot of what we're talking about right now, is understanding the materials on these old buildings and making sure that everybody is educated about what can and can't be done. We're used to working with newer buildings. Can't things be done quicker? And the older bricks cannot be treated like the newer bricks. Biggest challenge really is education of everybody on the job site to understand what we're working with and what we can and can't do, and have expectations of what we should do in order to make that building last another 100 years. That's probably the biggest challenge, really.
Would the steepness of the roofs or like more valleys to flash, would that something?
A more complicated roof. Yeah, a more complicated roof certainly makes it a lot more things to do as far as obstacles. When roofs have a lot of valleys in them, then yes, there's a lot more labor involved because you're cutting all those pieces to fit into the valleys. And access to some of these churches are the eaves edge is 60 feet up in the air. So you've got to build a scaffold system to just access that roof. And then the steepness of the roof, once you get past a roof that's about a 512 slope, once it gets steeper than that, it's no longer a walkable roof without a lot of helps. And a lot of those older churches are more than that. So if you have a 612 roof or you have a 1212 as far as the pitch is concerned, both of them are going to require a lot of legs hurting by the end of the project and needing a lot of those walkboards in order to access the roof. But yeah, the more complicated when roofs have parapet walls all around them, you have to flash up against all of that. But the more complicated roofs, sure, yeah, they're a little bit more work, but no different than other buildings.
Okay. Next question. What do you feel about the special ways that historic buildings are addressed under building codes? Do you find that each municipality applies the codes differently?
The codes are there for our safety. They're not always there for aesthetic reasons, and they certainly are there to keep us safe. If you're in a historic preservation district, typically the older buildings, if say the most common code that comes up with historic buildings is railing heights. Nowadays, they would want the railing to be 36 to 42 inches tall. And the old railings in the historic buildings were about 30 to 32 inches tall. So those have to be looked at before anybody can work on that building. Most, at least in the Grand Rapids area, they want, in the historic district, they want the railings kept to the original heights in order to not change the appearance, because it will change the appearance quite a bit if you take a railing that was 30 inches tall and then put a 40-inch railing up on top of that. You can really change the aesthetics of an outside of a building by changing those railing heights. But codes are there to keep us safe. And if it's required by the municipality that codes have to be followed, there's different ways or different things that you can do to try to work within those codes. Like with a railing, if they're requiring that the railing be at least 36 inches high, but the original house only had a 30-inch tall railing, you could still build a 30-inch railing, but then maybe do like a black bar or something like that can then be installed on top of that railing, so it's not as visually in your face, but it does meet the code requirements. So sometimes we have to get a little bit creative if we're forced to use code. But yeah, if the municipality is telling you make a change to this building, or if you're going to replace a railing, you have to bring it up to code, then sometimes it takes a little creative energies to make it look right, and you do what they tell you to do.
Okay, next question. Have you worked on many mid-century modern buildings? They pose a new array of problems in terms of how they were put together and what materials were used.
We haven't worked on many mid-century modern buildings. They do pose a lot of challenges in regards to their design and how they were built. We don't do flat roof work, which will take us out of a lot of mid-century modern buildings. Part of the mid-century modern movement too was to remove ornamentation from the buildings to make them as plain as possible. When you do that and you start removing cornices and window lintels and other types of things that help shed water away from the building, you then have water running right down onto the windows, which brings up some unique challenges. But we haven't really worked on a lot of mid-century modern buildings, due mostly because what we specialize in with the architectural sheet metal, slate and tile roofs, things like that, and the carpentry that we do, rebuilding columns, we're not really involved with that a whole lot, because that's not areas that we focus on. I would call us probably more closer like a classical architectural type of company, where those are the buildings we tend to end up at, because that's where our skills are needed more than not. But mid-century modern buildings do bring up a lot of challenges in the way that they shed water, and they're just in their architectural style.
Okay, I think that we will ask one last question. So from one of the attendees, I saw your presentation when MHPN had its conference on the Mackinac Island in this past May. It was great. And she said that you mentioned about getting more trades and craftspeople into the pipeline to meet the growing preservation activities. Could you talk more about your thoughts?
My thoughts is I wish we had more people getting involved in the trades. I could probably do an entire talk on workforce just in the way that building management is approached with workers. We've become so specialized in what we do with contractors and with the way we build things, where we have just concrete flat workers and that's all they do. And we have just siding guys and that's all they do. And we have just asphalt shingle roofers and that's all they do. We no longer have the master builders per se. We do have general contractors that'll oversee a project, but we're really lacking people who have skills that know a lot of different areas. So when the houses used to be built or the buildings used to be built, it was built by one contractor and he did most of the work with his crew. And we've lost that. Trying to get people into the trades is difficult. It's not encouraged, mostly online. When I did my talk up on MHPN, I brought up some statistics, or I brought up some examples of web pages where if I was a young person, I just went online and typed in best paying jobs. Most websites out of top 100 jobs maybe had project manager in it. There was never an electrician. There was never a mason. There was never a carpenter ever mentioned. Most of the time it was web developer or nurse practitioner, I think were the two top ones that I saw, which are people we need. But we also need tradespeople. There are some schools in the area that are starting to do trade schools, and they're trying to teach people who will want to do this for a living. But what I'd like to see is if we could get to folks who don't use this as a, well, you know, he did terrible in school, or that person did bad here. Well, he might as well get into the trades. We need people who are educated. You can really make a good living doing it. But I do have concerns of the future for building, and especially historic buildings, in order to have people who understand these materials, who are interested in learning about them and actually have worked on them. I'm hopeful that people will start to get involved. And I think the idea of the trades is becoming more acceptable. But right now we're feeling the effects of my generation, where I was told you go to college and that's what you do. I think we're really starting to feel the effects of that now. So hopefully that'll start to change. I encourage any young people that I meet to look into the trades, and I would ask everybody else listening to do the same. We really need some good people out here.
Hey, great. Thank you. Thank you so much for your time and this presentation. And thank you everybody for participating. You will receive an email when the recording is available. And our next webinar is scheduled for December 14th, and it's about the state tax credit. Hope to see you all then. And thank you again, Craig, for your time. And
thank you, Sean.
thank you.
Yes.
Bye.
All right. Bye-bye.